So hopefully you've looked at some of the instructional videos. So I just wanted to summarize about the shell method. I want to make sure you realize that you're going to get the same answer on the shell method as you get the disc and washer method. So you just need to pick the method that you like the best. The shell method is used especially when you're rotating around a vertical line or the y-axis and you have a y equation that is not easily convertible to an x-equal equation, because you have to do that under the disc and washer method. The shell method uses parallel rectangles or slices to the axis of rotation, whereas the disc and washer uses perpendicular rectangles or slices. And when you revolve the parallel slices and you accumulate all the slices, they make a shell. So we end up using the surface area formula 2 pi h to create our integral, whereas in the disc method you're using pi r squared. So now if you've watched the instructional video, you've got a general idea of this. But when you're going around a vertical axis of revolution, such as the y-axis, the shell method has 2 pi x bounds, a to b, and the radius p of x times the height h of x times d of x, the thickness. So when you're looking at this, the radius will just be x because it's the distance to your slice. So it'll always just be x. The height will be the function f of x minus g of x, and the thickness will just be your d of x. So you're going top to bottom when you're talking about the vertical axis of revolution in the shell method, opposite of the disc method. Now horizontal is 2 pi c to d, y bounds, y function, radius, height, and thickness. So your radius will always just be y, and your height will be right to left. So in this case it'll be g of x minus f of x times d of y. Now I want to summarize a comparison of the two methods, and the way I try to remember it is it's opposite of everything you've learned on the disc method. So if you look at vertical axis of revolution, a y-axis or another vertical line, the disc and washer method will do y values as bounds. There'll be x-equal equations. You're going from right to left. Notice you have pi out here and you're squaring. The shell method uses x values as bounds. You can leave it y-equal equation. You're going top to bottom, and it's just 2 pi times x, f of x minus g of x. So this is usually easier than converting to x equal for disc and washer. Now what if you're rotating around a line that's not the y-axis? So let's say we're rotating a line that's right of the functions. We'll call it x of a. In the disc washer method, remember you're going to say that value, if it was x equal 2, you'd put 2 there. So you'll go a minus your right function squared minus a minus your left function squared. In the shell method, you just do it in the radius part. So that sometimes makes it easier. So you just go a minus x, and then you just keep your top to bottom. So same thing if the rotation is to the left of the functions, x equal negative a. In the disc and washer, remember you add it to each function and square it. Whereas in the shell, you're going to add it to the radius and just keep your functions. So when we come to look at the horizontal comparison, like the x-axis or any other horizontal line, disc and washer uses x values as bound, y equal equations, top to bottom. So you have a to b, your function squared minus your function squared. The shell method uses y values as bounds, x equal equations. You go from right to left, and you just have y, f of y minus g of y. Now, same thing if you're rotating around a line that's not the x-axis. So if the line is above the function, we'll call it y equal a. Then in the disc method, remember you take that number and subtract each function before you squared it. In the shell method, you just take that number and subtract your radius, which is your y. And then you just have your functions f of y minus g of y. If the line is below the functions y equal negative a, then in the dish and washer method, you add it to each function before you square it. On the shell method, you just add it to the radius.